I'm going to show two different solutions to this, but there's kind of an easy solution and a harder solution. One of the solutions, though, one of the things that you want to start making note of is what are some strategies I can use, some algebraic strategies and some identity strategies you can use to help you show that one expression looks like the other. Okay, so one of the things I do is I often take a look at these expressions, and because I want to just look at the main Pythagorean identity, sine squared plus cos squared equals 1. I don't really want to worry about the other ones. I typically will change the secants or all the trig expressions into sine and cos, because everything can be expressed in terms of sine and cos, because essentially in the unit circle you can express everything with sine as y, cos is x. Okay, so that's one thing I'm going to try here. I'm going to just rearrange this expression. I'm going to make secant into 1 over cos x. Okay, and I'm going to make this 1 over cos x here minus 1. Okay, so there's my expression. I've got to adding these fractions in the numerator, so I'm just going to get a common denominator. So I end up with cos x over cos x plus 1 over cos x. Okay, the main denominator is going to be in the bottom here, is going to be, again, common denominator of cos x. So I'm going to end up with 1 minus cos x over cos x, or 1 minus cos x all over cos x. Okay, and then when I simplify this expression, notice that this expression here is starting to look like that one there. These cos x's can simplify out, and I end up with cos x plus 1 over 1 minus cos x. So left side equals right side. Done. Okay, so that's one way to do it. Okay, the strategy, again, it's important to start making note of these strategies. These strategies are what's going to be important when you start dealing with identities that are not as simple. Okay, so what I want to try doing is I can show this using a different strategy though, and there are going to be infinite ways to solve these trig identities. Okay, there's many ways you can do this. You don't have to do it exactly how I've done it. I made lots of answer keys for these, and these are just showing one solution. There's many ways you can do these identities. So I'm going to show you a one-step solution here. So this solution looks like this. I know that cosine times secant is equal to 1. So what I can do is I can multiply the top by cosine and the bottom by cosine x. And if I multiply a fraction by 1, I don't change the fraction. But what I do is I end up with is, when I multiply that out, cos x times 1 is cos x, secant times cosine is 1, cos times secant is 1, 1 times cos x is cos x. Okay, so now I have left side equals right side. That's a one-step solution. I also notice here that I didn't state the non-permissible values to start with, so I should really state those at the beginning, but I'm going to state those now. So non-permissible values are when cos x equals 0. Okay, because we can't have the denominator equal to 0 here. I also have cos x not equal to 1. Okay, because 1 minus cos x will give me the 0 in the denominator here. Okay, and that also helps here because secant, when cos x is 1, secant is 1, so that's my 0 in the denominator. And again, you could solve for x as well, but at this point we're just going to not bother solving for x.